So, hello everybody. Welcome to our October Tech Bite. Um, Today's is a little bit different, I guess, of a topic. Important one though. Uh, Checkpoint's been in cloud security for years. 10, 12 years, maybe more at this point. And we've acquired and built a variety of protections and tools to help you on your cloud journey, as they like to say. Um, the thing that is interesting is as the cloud evolves, as the security concerns in the cloud evolve, so too has our messaging, right? And so to that extent, we have a presentation I wanted to show you guys, fairly new here, talking about shifting the paradigm of cloud security, right? And what does that look like? What has been and what should be, and how do we approach the cloud, right? So without further ado, over here and click. There we go. So real quick, today Checkpoint has over 3,700 customers who choose Checkpoint to secure their cloud applications in AWS, Azure, GCP, Ali Cloud, Oracle Cloud, etc., ACI, all that stuff. And they use a wide variety of Checkpoint technologies to secure those applications. We secure over 800 million assets. And think about that, 800 million assets. It's almost a billion. It's a huge commitment. It's a huge commitment from us as well as our customers. We're securing the largest cloud environments in the world. And with our partners, we recognize our leadership in that space, right? And you can see from leadership, in the last year alone, we've received 10 different recognitions around cloud security. We were selected as the #1 cloud network security vendor. We're the only vendor to provide a solution that preemptively prevents unknown 0 days. Things like MOVEit and Log4Shell, when they were brand new, we prevented them in the cloud. We continue to be leaders in that field. I think you guys have heard this or something similar, in some of these presentations. So let's talk about the cloud for a second, and really to describe the paradigm shift, we kind of have to describe how things were / kind of are, right? If I'm looking at a simple conceptual cloud, right? Let's say this is AWS, for example. The cloud has a front door and a service door. The front door faces the internet, right? And here we have it here. This is where I have my users. And for instance, let's assume I'm a real retailer or with retail applications in the cloud. My users will use the front door to access my application, usually via HTTPS or SSL or an API. I also have devices connecting from the front door. For instance, I have mobile devices, right? My users using the app on their iPhones or on their Androids. I also may have SaaS applications that are interacting with my cloud applications. So that's the front door. The service door is the other way, right? All my power users come through the service door that maintain and make my cloud work. Developers, they come through the service door and do their development, integrate environments and applications, etc. We have DevOps teams in there. Sometimes we have contractors. You see the contractors in the picture who need to access the cloud for whatever reason. And often, very often, we have our data center, our on-premise or whatever data center connected through the service door. So this is kind of the way the cloud is today, right? And I think this is, fairly fairly straightforward to kind of visualize and understand, right? So what's the problem with today's architecture? The problem is that the hackers also can use both of these doors, right? The front door, they try to launch your typical attacks from the internet, like a SQL injection, right? Or the OWASP top 10, right? They also can do some scanning, right? And see that you have exposed assets on the front door and maybe understand a little bit more about ports that are open on them and what versions of their software they're running and CVEs on that, etc. Right? On the service door, we tend to see more mature, more escalated kind of attacks, right? A lot of times we can see leaked credentials, right? The admin credentials have been leaked through one way or another, and hackers are accessing with admin rights. You could have a contractor that you trust or used to trust or what have you, who still has rights that we never got revoked. And then the other thing is the developers have, blanket access to these tools, and we don't know if their device, there's a possibility their devices are compromised, right? And once in the cloud, the hacker will see all the different vulnerabilities, the risks, the issues. For some of them, could be exposed secrets, could be over permissive identities, could be sensitive data, exposed assets. It could be PII information. I mean, it could be almost anything, right? Misconfigurations. And this puts us at a real risk, right? Because there are thousands of pieces of information and PCI and misconfigurations and vulnerabilities. There's thousands of these things that are present within your cloud assets at all times. And the other issue is you may be able to find these vulnerabilities, right? You might be able to find a lot of these risks, but they will be in the hundreds and the thousands and the hundreds of thousands. Um, no one can handle 100,000 alerts, right? It's just not feasible and it's not scalable, right? You need an army, but that's the reality, right? So it's a very dynamic environment and there are risks and the risks change, right? And that's important to understand that, hey, let's say we did fix some of the risks today. The problem is that things shifted and changed and the cloud is ever moving. And so when you fix the problems right now, a new problem or the same problem could spring up an hour from now. You're kind of fighting a losing battle doing that. And because these assets are all interconnected, as you see in the picture, when the hackers find their way through the front or the service door, they jump and they exploit and they move laterally from one asset to another. They'll steal whatever important data. In this case, the PII that's on the database, right? They went through the web application, used Log4j on a VM. They found account with excessive permissions, right? And then they were able to grab the PII, right? So, in summary, what we just saw, too many high risks are open daily in the cloud, really, really by the minute, forget about daily. Many of the critical risks are unknown. The remediation process is too slow. And CISOs have kind of lost control to DevOps, right? So now what are we going to do about it? It's time to stop chasing these risks, right? It's time to get in front of them. It's time for a paradigm shift in cloud security, like we were saying with the topic of this TechByte. So what are we talking about with this paradigm shift? You need a cloud native application protection platform or CNAPP that includes prevention, not detection, not, oh, we'll mop it up 3 hours from now, actual true prevention at the time. And you've heard that ethos from us in 1,000 different ways, right? Not just here. So at Checkpoint, we're taking the CNAPP, we're adding another P for prevention. And to do this, we're really using 3 different products in like a single platform, which is why we're calling it CNAPP as its own platform. The first is the WAF, Web Application Firewall with API security. The second is adding network security to your cloud. And the third, using the CNAPP platform. This is our solution. This is how we give control back to the CISO, to the security experts, et cetera, right? Because we can't just knock on the developers' doors and say, would you mind fixing this vulnerability? That's not scalable. That takes too much time. By the time they fix something, two more vulnerabilities have occurred. So it's just not, just doesn't scale. So let's go back to our story, right? In our story, we had different types of alerts, thousands of alerts. And what do we do? So here's the three recommendations. Here's how we apply those three technologies. The first, we're going to put a WAF on the front door. Now, this may seem like 101 stuff, very basic. The odds are you probably have a WAF in front of the front door. But you don't want to just put any old WAF. You don't want to put, the ones that the cloud vendors give you for free, right? You're getting what you paid for. It's not useful. It's not proactive. It's not preventative. You need a WAF that will protect you from 0 days, right? Because that's what we're really afraid of anyway, is variants in 0 days. You need a WAF that isn't based on signatures or just looking for the top 10 vulnerabilities. You need one that inspects and protects your APIs. That's the hooks into your cloud, right? That's what applications use the most to communicate is the APIs, right? And once they're exposed to the internet, hackers can use them and automate their attack, right? So you see here, CloudGuard WAF, 0 day prevention is immediate. On average, the cloud native WAFs would take 40 days. 40 days. Imagine if someone is a resident in your data center for 40 days. That's what's going on here. It's just in the cloud, not inside of a building. Um, you know, they base the WAF off of signatures. We have, all the herbs and spices of Checkpoint, right? Highest block rate, API prevention is often not provided by the cloud native WAF, right? And important to think about for all of you with multi-cloud, right? If you got a little AWS, a little Azure, a little GCP, a little Alibaba, a little this, a little that, you're making a different WAF with different policies on each one by using the native application, and you may not be able to replicate the same security policy with the same protections across all of them. And here's like I talked about 40 days, right? Here's how long it took us and how long it took the native WAFs to block these, famous 0 days in the last few years, right? Log4Shell took them 5 weeks. It took them a week for Spring4Shell, Text4Shell, 31 weeks. MOVEit was 6 weeks. So you see how this is going, right? That's what happens when you deal with signatures, is you got to sit around and wait for a signature. Our WAF can be deployed as a plugin for hyperscalers, also for Node.js, Kubernetes, Kong, different types of web services. You can even do some things with on-prem with it. It's great. And the other thing is, what's cool about it is because it protects the APIs, it actually will discover the APIs, right? So you may find out that you've got hooks out there you didn't even know existed from the WAF, right? So it's important. So step one, let's put a WAF in front of the front door. A good one, one that is preventative of 0 days. Step two, we need a good network security solution. This network security solution should provide you with macro segmentation based on applications. In the past, we had our applications in VNets or in separate VPCs, and we had multiplications in each VPC. And our cloud network security solution is a hub and spoke. It sits between the VNets, between the VPCs, between both, and we perform the connection automatically, and we do auto discovery of these VNets and VPCs, right? This is important. The whole hub and spoke architecture is fully automated. Once you get it going, it scales itself. So what you could do is you put your applications in dedicated accounts, connect them to our landing zone account, and you can deploy network security on its own in the landing zone in seconds, right? Providing you micro and macro segmentation. And again, yes, the cloud, there are cloud native firewalls, right? AWS, Azure, GCP, they all offer one, but you see it right here, right? Limited IPS. Checkpoint has the best IPS. Yeah, Checkpoint has the best security out there, right? And it's proven over and over with our firewalls and other things, right? So, you know, we have the best security. We support hybrid cloud. Again, you're going to have to configure three different firewalls with three different, UIs, three different policies in three different clouds, right? But here with us, we do a multi-cloud, right? Um, and then, some of the deeper things about our firewalls in the cloud. And the firewalls in the cloud are the same as is essentially the same as the hard firewalls that we sell and we've been selling for 30 years. They're that mature, right? We do deep packet inspection on all protocols. We do identity awareness through a variety of different providers. We have the 0-day prevention. We have the 99.8% malware catch rate, whereas the native firewalls don't go into those tests. So who knows what their catch rate is? And we have the advanced logging and reporting that you're probably familiar with if you're familiar with Checkpoint, which I think almost all of you should be. Um, and then going back to simplicity, right? We made sure we integrated tightly with the WAN networking infrastructure, right? So we spend a lot of time working with the major cloud providers, right? Checkpoint wants to do this hand in hand. We don't want to go on our own, right? Um, they've all come up with their own version of WAN technology in the last year. Azure has vWAN, AWS has Cloud WAN, Google has what they call Packet Intercept. We've integrated with all those, and so they're all unified, right? So that's part two, right? So we put the WAF at the front door. We've segmented this network, you know, and macro and micro segmented it through the networking portion, right? But the final recommendation is a prevention first CNAP, right? Don't use any CNAP. You need one that is built around prevention. And let's kind of talk about that, right? If a CNAP is detection first, it is going to generate thousands and thousands and maybe hundreds of thousands of alerts, right? And you're gonna sift through a sea of information, that needle in a haystack you always talk about, right? I got 1,000 alerts. What are the three that are the most important, right? And I got to fix that because this is a detection product, right? Um, our a CNAP that focuses on prevention, our CNAP tells you, hey, we have all these alerts. You can look into them, but we remedied pretty much all these. And the last few that are most critical, we bring to the top so that they're there. On top of that, here is our recommendation on how to fix it, right? Because we want you to do it and do it quick, right? Went too far. Gotta go back one. Sorry about that. We take all those alerts, we use a vast array of engines, right? And the modules that I'll talk about in a second, like, a whole bunch of modules, and we'll talk about them in a second, right? We use all of them to categorize and understand the level of risk on each individual alert. And once we understand that, we can use a risk calculation module that takes into account the exposure level, the data sensitivity, the criticality of the application, a few other things. And we essentially divide the risks into like a magic quadrant in our tool, right? Those that are most sensitive and those are the most exploitable, right? And this is kind of something that makes us unique, is that you'll see the upper right, the ones that are most exploitable and most sensitive, you'll see them first, right? And they'll be ranked on their criticality, right? That they're the most critical, right? So for instance, if we know you have a web application that's vulnerable to Log4j, we know it faces the internet. Every other CNAP vendor will tell you that this is a problem, right? But with Checkpoint, the CNAP will tell you, listen, I know you have this problem, But since you have our WAF in front, and because we know how to block it, the problem has already been virtually patched for you by the WAF. So in effect, we will reduce the severity of the alert. It won't appear in a high risk quadrant, right? Here's another example. Let's assume that you have an RDS, sensitive data in AWS. Let's assume that this RDS is configured so anyone can access it. Any other CNAP will tell you this is a critical risk. But again, with Checkpoint, it's going to tell you, listen, this RDS is in one account in the AWS, but I see there's Checkpoint network security, the firewall, in the service door. So it's not really facing the internet because we are protecting it and segmenting it through Checkpoint's network security. The severity goes down, right? Because while it may look exposed, in reality, very few people can access it, right? Those are two like somewhat, straightforward examples, right? And once we find these issues in your cloud, we provide detailed steps on how to mitigate them, how to communicate them directly to your developers and your DevOps. This can be done via Jira and ServiceNow and Slack and a few other things. It doesn't end there. We also have these cloud bots, right? And we've had the cloud bots for a while. They can perform mitigation automatically. They'll take the steps that we recommend and do it for you, right? And lastly, we keep you informed, right? We always want to keep you informed. And again, here's another one of these charts, the CNAP. Our threat intelligence is the best around, right? We have more cloud services in our inventory, more posture rules in our CNAP, code and runtime protection. We detect overprivileged permissions, etc. Right? Mouse at. And we also have introduced some stuff that's very new. Threat analysis and visualization. I'll talk about that in a second. Threat detection, we correlate it to the MITRE attack risk now. And we can find what we call a toxic combination of vulnerabilities, right? So again, with that ranking system we saw just now, the MITRE attack, we could say, hey, if X happens and Y happens and Z happens, then the risk is high. But if only X happens, then the risk is low, right? So we kind of have this toxic combinations, we call them. And here's, the here's the 8 modules and 52 engines. I mean, this is like an eye chart, but you see we have all these different engines all working at the same time to help you secure your cloud, right? And do a prevention first approach. We also have the blueprints. We have security blueprints for Azure and AWS, based not just on what you get from Checkpoint, but also how it integrates with different platforms. And for each of them, we take you through the process, explaining what you should do, where you should do it, how you should do it, why should you do it, right? So these blueprints are extremely handy for someone who's, still getting their feet wet in the cloud. So just to wrap it all up, for many years, we've had these problems with our clouds. We've allowed developers and DevOps to create their own accounts, and these accounts have been exposed to the internet. We couldn't control them. Some of them got leaked, some of them got misused. We allowed developers to do pretty much whatever they want because they want to move fast. We want them to move fast, and we still want them to move fast. But luckily, our cloud has better practices, right? Today, developers and organizations cannot create their own accounts, cannot connect them to the internet or the corporate network on their own. And today with Checkpoint, we have a solid blueprint for how to apply a prevention first strategy and technologies that allow us to do prevention first and prevent attacks from both the front door and from the service door, right? We produce that technology that allows customers to secure their cloud the best way possible. Prevention first, and then remediation second. And I know that was a lot of presentation and much more that we're used to on TechBytes, but thank you very much. So I'm going to check real quick if there's any questions. Yeah, I got one. So the question is essentially the question is, are these all managed from one spot, right? That unified dashboard. And the answer is absolutely yes. These three things are all managed from the Infinity portal. If you're familiar with that from, some of the other technologies we have, they're all managed from the Infinity portal. One pane, one single pane of glass, as the old saying goes. Are there any other questions? No. Well, thank you very much, then. Appreciate it. Thank you for joining the Tech Bite, and hope to see you on next month's.